and welcome to the video on linear regression. In this video, I'll tell you about the linear regression algorithm in machine learning, and after the presentation and the theory portion is discussed, I'll also show you the practical implementation of linear regression algorithm with the help of sklearn in Python. So, linear regression is one of the easiest and the most popular machine learning algorithm. It is a statistical method that is used for predictive analysis. Linear regression makes prediction for continuous or numerical values such as sales, salary, age, product, price, etc. etc. Now, linear regression algorithm shows a linear relationship. It tries to establish a linear relationship between a dependent variable y with one or more independent variables x. Now, that's why, because it is trying to establish a linear relationship between the target and dependent features, that's why we call it a linear regression algorithm. Linear regression shows linear relationship, which means to find how the value of dependent variable is changing according to the change in the value of independent variable. The linear regression model shows or provides a sloped straight line representing the relationship between the variables. Consider these images. Now, here on the y-axis we always have the dependent variable or the value that we are trying to predict, and on the x-axis we have the independent variables. So these are all the data points, and this is the basically the line of linear regression that we are trying to plot. So if in case in future we get a new data point somewhere over here, then we can simply put or place it with the help of the line of linear regression and tell the value of the dependent variable or predict the output based on the independent features that we are getting for a new data point. Now let's understand positive linear relationship. If the dependent variable increases on the y-axis and the independent variable increases on the x-axis, then such a relationship is termed as positive linear relationship. So this is the image for positive line of linear regression. So the equation for this line can be given as y is equals to a0 plus a1x. Now all the linear equations for a straight line that we learned in the high school can be derived from that equation, like y is equals to mx plus c. So m is the slope and c is the intercept. So here if we try to map that y is equals to mx plus c with this equation given over here, so a1 will be mapped to m and this a0 will be mapped to c. So the equation of the line becomes y is equals to mx plus c or y is equals to a0 plus a1x. Now this, clearly by seeing we can say that this is a positive slope of the line. Similarly, we can also have the negative slope here. So the equation, because this is a negative slope or negative line of regression, will have a negative value in the equation. Why do we get such negative line of regression? Because the dependent variable decreases on y-axis and the independent variable increases on the x-axis. So the value of x-axis increases but the value of y-axis keeps going down. That's why we get a negative linear relationship. Now let's move to the Jupyter notebook and try to implement the linear regression algorithm in sklearn. So let us start with the practical implementation of linear regression in Python. First of all, I'll import all the required libraries. So let me import numpy as np, import pandas as pd, and import. I'll also show you the visualization for linear regression. So for that I need matplotlib dot pyplot as plt. So these are all the required libraries. Now let me get the dataset into a pandas data frame. So pd dot read underscore csv, and I'll be using a salary data dot csv. And if I want to show you how the dataset looks like, so it says salary. Okay, I have made a spelling mistake. Now we have the salary data. So let us look how our dataset looks like. So here, this is the dataset. It has two columns, years of experience and salary. So the salary will be our target variable and years of experience will be our x fee or the independent feature. So based on the years of experience, we can decide the salary of that employee. Now, so let me split x and y axis. So on the x, the independent feature will use dataset dot ilog. Here what I'm going to do, I just want to select all the rows and only the values of years of experience, and y will be my data set dot ilook. And here what I want to do is, okay, I forgot to put a comma over here. Now here what I want to do is dot values. So now I have my x and also here I have my y. So these are x and y for our machine learning model. Now what I'm going to do next, I'm going to split my dataset into train and test. So we'll use 70 or let's say 80% of the data for training, and then we'll evaluate or test the model on the remaining 20% of the data. So for that I need to include from sklearn dot model underscore selection import train test split, and then I want to make x train, then I have x test, then y train and y test, and I will call this train test split, and I want to make split on x and y, and the test size I want to use only 20% of the data for test, and then I want to use the 80% of data for training. So this will import the train test split feature that sklearn gives us, and then will separate out the data from the entire data set. That's it. That is, we will keep 20% of the data for testing, and then we'll have the 80% of the data for training. So after doing all this, finally we'll import the linear regression model. So from sklearn dot linear model import linear regression. It will take some time to import the model, and now what I'm going to do, I'm going to make the instance of the model, let's say the regression object, and this will be of linear regression. So this is the regression object, and now I'll use the fit method. So to train the model on the training dataset, we use the fit model, and we want to train it on x train and y train. So now we have a ready-made instance of the model. Now let's check the prediction of the test. So y underscore pred will be equal to ridge dot predict. So this is the predict method that we are going to use, and here I'll write x test, and x pred will be equal to ridge dot predict, and here I have the x train. So these are the predictions. Now let's visualize all this. So for that I need to use matplotlib. So plt dot scatter, and here what I'm going to do, I'm going to plot x train and y train, and let me plot this into green color. Now this will be the scatter plot. So these will be the data points, the training data points that we had in the training set. Now I want to also plot a line, the regression fit line from the x train and y train. So x train, and I have x pred, and here the color of the line I want is red, and then plt dot show. So if I run this, now here I am having the years of experience on x-axis and the salary on the y-axis, and this is for the training dataset. So let me also print something over here. So print, this is for training set. For training set we have this plot. Now let's also make the same plot for the test, that what we got from our linear regression output. So what I'll do, again I'll make a plt dot scatter. Inside the scatter plot, this time I'll have x test, and then I have the y test, and color will be let's plot the data points in blue. Plt dot plot. Now here I have xtrain and xspread, and again color, the line I want is red, and plt dot show, and this is for testing dataset, so test set. So this is how our linear model is working. We are actually getting a very good fit line that is able to predict the linear relationship between the number of years of experience and salary of the employee. So I hope you are very clear with the implementation of linear regression in Python. Now let's move to the next video. Thank you.